Hello, fellow humans, and welcome to a tutorial series about learning to program with processing. This series is going to be geared to those who have never programmed before, so if you're looking for quick tips or a quick concept tutorial about processing, this probably isn't going to be the series for you. We're going to be going slow, and we're going to go in depth about various computing concepts and exploring those concepts and visualizing them within processing. So what is programming? Well, Wikipedia defines it as this, but let's try to flesh out what it is on a more easy to understand level. Programming, at its heart, is a tool we have to make a computer or system do what we tell it to do. Computers are machines that, well, compute. They don't understand human language. Instead, they communicate with ones and zeros. More specifically, electrical currents. This series isn't going to go delve into deep detail about how a computer works. That's for another day, but it's useful to understand this at a basic level. So, all you need to know is that we can't speak directly to the computer, and that the computer can't speak directly to us. There's got to be a middleman in there, and the middleman is what we use as a programming language. We write in a programming language, and then the compiler of the computer transforms it into a language that the computer can use and then execute accordingly. So we, as programmers, write programs in a language instead of writing in ones and zeros, because that would get really confusing. So, thus comes the question of what language do you choose to write in? And there are tons of languages you can choose to write in. There's C, C++, there's Java, JavaScript, there's Python, there's tons. And they all have their uses, and the one that we're going to be using is processing, and more specifically using Java, but processing on top of it. And that because I think that it's useful when you're learning to learn at a visual level. That's how I learn. I'm a very visual learner. And so being able to have these concepts and flesh them out with code that allows you to actually understand what's going on, I think is very, very useful. So a lot of tutorials out there start with learning C++, for example, because it's very useful later on when you can get super good at it. But it's all pretty much console-based and very boring to look at and not very interesting to see what's going on under the hood, because whenever you do try to figure out what's going on, you have to go through a debugger and it's a whole mess. But processing is great because you can actually have a little rectangle that has a value associated to it that is how long the rectangle is, or something of that nature. So, with that being said, it's time to download processing. So I'm over on the processing website, that's processing.org, and there's a ton of good information here. You can go and check out all of their references. You learn everything you want to know about the various things you can do in processing. It's a great place to get started when you're trying to learn something. But we're going to go ahead and go to download, and download for our Windows 60-bit computer. And it's going to go ahead and save a zip file to us that we can go ahead and extract. And it's also going to ask us if we want to pay for it if we want to, because it's absolutely free. It's donation. It really helps them out because they're making free software. And I use it all the time, so I've supported them in the past. But we're going to go ahead and we're going to open up our downloads folder and find the processing zip that we got. And we're going to go and extract it. Perfect. And then I'm going to go ahead and place it onto my desktop so that it's somewhere that I can easily find. You can place it into your documents folder. You can put it onto your, anywhere else on your computer. Okay, it finished extracting. So I'm going to open up this folder and then take this one, and I'm going to move it into a folder that I made previously called processing. And then we should be able to open up the application if we go into this folder. And then click on the processing application, and it should start up right away. So now that we've got processing downloaded and we've had a little bit of discussion about what programming is, we aren't gonna actually program right now because I think there's a few extra concepts that I'm going to go over before we actually flesh out what exactly you can do with code. I'm going to try to explain it without code at first. So I'll see you then. The first concept that I wanted to talk about is data types. So what I've got here is a collection of values, each separated into different data types. Over here, we've got integers. Here we have floats. Here we have strings. And then here, you can't see it. Here, we've got Boolean values. So what are all of these things? Over here, you can kind of see that there's numbers. Maybe these ones are decimals. And then here we've got words within quotes. And then here we just have the value true and false. So let's go into more about what these are. We'll start with the integers. Integers are whole numbers. They are the counting numbers. And examples include 1, 2, 3, 0, -3, -2, 47, 123, anything that doesn't have a decimal after it. It's just the whole number. The second one, floating point values or floats. These are numbers that have decimal points after them, such as 1.1 or 0.25 or 3.1415926, yada yada yada. Also included in this set are the whole numbers as well, but we have to say them as 7.0 because we want to make sure there's no loss of data. We want to make sure that it stays as a floating point value, even though the value is 7, it's equivalent to it. We say 7.0 for our own sake and for the computers so that we know that it is stored as a floating point value. The next type are strings. And strings are just words. Anything that is within double quotes is a string value. So these are words, and the name comes from characters that are strung together. So like the word you is the character Y, the character O, and the character U, and they're strung together one after another. So you. This also includes like anything within quotes. So 7.5 is a string if it's within the double quotes. So this is not a number. Don't get confused. 7.5, this is not a number. This is a string because it's within double quotes. And then the final type are Boolean values. These are true and false. And we can use them however you would use true and false. So is 1 equivalent to 1? Well, yeah, that's true. Is 2 equivalent to 1? That's false. That's not true. Is 2 equivalent to the string 2? That's also false because strings are not numbers. Side note, if you're using something such as JavaScript, which is not a strongly typed language such as processing or C++, then this actually will come up to be true because the two values are interchangeable. However, in processing, this is false because 2 is not the same as 2, if that makes any sense. So, what can we do? Now hold on just a minute. Before we move on, I'm gonna do a game show! Ha! Well, not quite a game show. It's more of like a quiz about data types. I'm going to write out some value onto the screen, and then you have to decide what data type it is. And if you get it right, you get a point. And if you get it wrong, sorry. And there's no prizes, so you do you. Anyway, so what data type is this? If you said integer, you're correct. That is. It's a 7. What about this? What data type is that? If you said that that is a float, congratulations, that's correct. If you said that's an integer, you're kind of not correct. The 0 does matter. We're talking about a floating point number that has extra information. The extra information is 0, but it's still extra. So it's important that we make that distinction. What about this? What type of value is this? If you said that's a string, correct, that's right, it is a string. Anything within double quotes is a string. If you said this was an integer, I'm sorry, that's wrong. It's within double quotes, which makes it a string. Anything within double quotes is a string. And what about this? If you said that's a Boolean value, probably before I even finished writing, correct. That is very correct. It is a Boolean value. Others include false. Now, what about this one? What about this? Tricky, tricky, tricky. If you said that this is a string, correct, it is a string. I tried to fool you. You probably didn't fall for it. I know, you're smart. This is a string. Even though it says false, it's not a Boolean. It's a string because it's within double quotes. With these values, I think it's interesting to see, like, yeah, we can have them, but what can we do with them? So I made a little table over here. We're gonna start with the integers and the floats, and you can do anything that you would imagine you could do with them in math. So you can add them together, like 2 plus 7 is 9, a quarter plus 3/4 is 1.0 because it returns a float, not an integer. And you could subtract them, which makes perfect sense. You can multiply them together, again, this becoming 1.0, not 1 because it's a floating point value. And then when division comes, it gets a little bit tricky because when the computer divides two integer numbers, the result is also an integer, and so 30 divided by 4 is 7. While if they were floats, such as 30.0 divided by 4.0, it would give you the proper result of 7.0. Just something to be careful of. And then strings, you can also add strings together because that kind of makes sense. Like me plus me gives you the word meme, or me plus 7 gives you me 7. Which might be a little bit weird, like, oh, you're taking a string and you can add a number to it? That doesn't make any sense. Well, the computer actually sees this 7 and it makes it a string. So there are these magic quotes here that you can't see because one of the values is a string. It converts the 7 to a string to make me 7. However, this doesn't work for me minus 7 because it doesn't make any sense to subtract a value from a string. We're gonna get back to that in a later date, but just know that this doesn't work at all. And then, another thing we wanted to do is after we have these values and we know what their types are, well, what does that mean? You know, what can we do with them? You can have the value 4, sure, and then it just goes away into the ether after you use it. So how do we save the value 4 so that we can use it later? And we do so using a variable. If you've ever taken an algebra class, you're probably familiar with these with x and y, storing coordinates on a plane, or just a function like 7x plus 2 is y. And then you have to try to figure out what the values of x and y are. Very similar here in computer science. We have these variables that have types, and we can use them to store data for later use. So over here, the way that we create a variable is we have a variable type that we define. We've got the variable name. We have this symbol, which is the equal symbol, but we actually call it assign. So we assign a value, assign the value to the variable, and that's how you create a variable within processing. So for example, we've got an integer position equals 57, so we assign the value 57 into the variable that is type integer and it's named position, if that makes any sense. Some more examples: float rate, assign the value 2.77, and string name, assign the value Ian, for example. And we can use these variables how you would use them kind of in math. So you have this variable counter and it's set to the value 7 currently. And I displayed it here. And we can take that counter value and add 5 to the counter value. So we take the value counter which is 7, sorry, and we add 5 to it so that we get 12, and then we assign 12 to the value of counter. So now counter is equal to 12. And a shorthand we can do instead of saying counter is equal to counter plus 5 is we can say counter plus equals 4, and that just means take the value of counter and add 4 to it. And the value would get after that would be 16 because it's updated to 12 already previously ahead of it. Okay, so one thing that I wanted to go over in addition to, since we're talking about variables and we've kind of discussed math in a sense, is in algebra class when you've drawn a graph onto the whiteboard or piece of paper, you typically draw something that looks like this, right? You've got a coordinate plane, and then this axis is the x, this is the y, and then x increases when you're going this way, and y increases when you're going this way. This is perfect for math, but a computer screen doesn't work like that. A computer screen has coordinates that are like this, x increasing to the right, just like in math, but y increases downwards. And this is an artifact that's left over from when we had TVs were starting to pop up, and the cathode rays would scan across the screen left to right and then downward. So as you went further down, it was further in time. And computers still use that system today. And so what do we represent in this system? We represent little pixels on the screen. Tens and tens of thousands of pixels on the screen. And they're given a value, just like in math, of x comma y to represent a point. However, here we're representing a pixel, which is a little box on the screen that has some sort of value assigned to it that's a color. And then that's how computers draw pictures onto the screen, is they have thousands of these little pixels all clumped together of different colors to present an image onto the screen. So that's how the coordinate system works on a computer. The 0, 0 starts in the upper left-hand corner of your screen. As you go to the right, the x coordinate increases. As you go downward, the y coordinate decreases. If you go up, the y coordinate decreases. And if you go to the left, the x coordinate decreases. So how can we use this in order to draw something on the screen with processing? I'm glad you asked. So if we come to over here, I've got some information regarding some of the functions that we can use to draw something to the screen. These include ellipse, which draws a circle or an ellipsoid onto the screen. We've got rectangle, which draws a rectangle to the screen. We've got fill, which designates the color of the image that you want, or the color of the shape that you want onto the screen. And then we've got stroke, which is the outline of that shape and the color of it. And the way that we use these is we say, okay, ellipse. I'm telling the computer I want to draw an ellipse. And the computer goes, okay, I know how to draw an ellipse, but I need a few things from you. I'm going to need the center of that ellipse, and I'm going to need the two radiuses, or the radii of the ellipse. So we can give it to the computer by putting those information within parentheses. And we say, okay, the first one is going to be the position of the center, but the x coordinate. And then the second one is the y coordinate of the center of our ellipse. The third one is going to be the radius of the x coordinate, the x radius of our ellipse. And then the fourth one is the y radius of our ellipse. And I'm going to demonstrate these in just a moment within the processing environment, and also give you a task to do before next episode. And then same thing for the rest of these. Rectangle, the computer knows how to draw a rectangle, but we have to give it some information. So we give it the position X and the position Y of where we want it, along with a width and a height. And rectangle is a little bit different from the ellipse, because the ellipse, we tell it the center of some circle, while for a rectangle, we actually tell it the upper left corner of where it belongs, and then the width goes this way and the height goes downward from it, which is a little bit different from the circle. So be careful when you're doing that. And then fill, we have to give it a color, and computer color is represented in 3 channels of red, green, and blue, ranging from the values of 0, meaning no color is there, to 255, meaning that's full color. So if you wanted to represent a yellow, you would want to have the red all the way up and the green all the way up, but have 0 for the blue because you don't want any blue in there. So the color yellow could be something that's, red 255, green 150, and then blue 0. So you can get a little purpley color. Or not a purple, a yellow color. Pardon me, I'm biased towards purple. And then the same goes for the stroke. However, this doesn't represent the color of the shape, but rather the color that borders the shape or the outline of the shape. So let's jump into processing and let's try out a couple of these so that you can see what they do. So I'm in a processing sketch right now. And when you open up the processing exe, you should get something that looks like that. And then before we get started, I'm gonna go ahead and save this so that I can use it later if need be. I'm gonna call it face for a reason that I'm gonna explain in a second. But let's go ahead and explore some of the things that we can do within processing. Before we actually draw anything to the screen, we have to let processing know that we want a screen to appear. And the way that we do that is we type the word size, followed by parentheses, and then inside of the parentheses, we want to give the processing window a width and a height to represent it. So we take size, and let's give it something like 600 pixels by 600 pixels. And then when we run the program, we should see now we have this window on the screen that's 600 pixels in width and then 600 pixels in height. I'm saying pixels so many, it's starting to sound weird. But we've got this canvas to paint upon, and we can use that to put something onto the screen. So let's go ahead and demonstrate a couple of the tools that we learned just recently. So let's go ahead and draw an ellipse to the screen. We say ellipse with parentheses behind it, and then a semicolon at the end to tell processing that we're ending this statement. So you end every statement with a semicolon so that the computer knows to move on to the next. And then if you remember, an ellipse takes a position for the center. So let's center it at 200 pixels. And then it gives it a width radius and a height radius. So let's give it a width of 200 and then a height of 100 so that we can see it as an ellipse. And if we run this, now you can see within the processing window, we've got this ellipse that's centered at 200, and then has a width of 200 and a height of 100. So it's twice as twice as fat as it is tall. And then also, let's demonstrate the rectangle, which we say rect followed by 2 parentheses and then a semicolon afterwards. And then inside of the parentheses, we got to give it a coordinate for the upper left part of the rectangle. So let's put it at the same place so that you can see that. And let's also give it a width of 200, 100, a width of 200 and a height of 200, or 100, sorry. And then let's go ahead and see what that looks like. So you can see that it's not the center of the rectangle. It is indeed the left top corner of the rectangle. And it has the same height and same width as the ellipse, but it's just skewed a bit because of that distinction with the corner rather than the center. But you can see that they're the same size, but just different shapes. And then let's also go over fill and stroke. So remember, fill takes a color, and you want to give it 3 colors to represent the red, green, and blue channels of the computer screen. So let's go for the kind of yellowish color that we were saying before. So we give it 255 for the red, maybe 175 for the green, and then 0 blue. And then we can go ahead and run it. And now you can see that our shapes are this orangey yellow color. A quick tip you can do, if you go up to here and click on Tools and click on Color Selector, it actually opens up a little window for you to choose any color that you want to. And then it also displays the red, green, and blue values for you to place into your scene so that you can choose a color directly without having to guess what those values would be. So now we have this sketch that just is two shapes and that they share a color. But what if we wanted the shapes to have a different color? Well, computers work sequentially. It does one step after the next. So this first line runs first, and then this line runs second, and then it draws the ellipse and draws the rectangle. So that's why the rectangle was showing up over top of the ellipse, is that it was drawing the rectangle after the ellipse. So we can reverse these if we wanted to. So we can draw the ellipse after we draw the rectangle. And then now you can see that the rectangle is behind the ellipse. And then we can also have them be different colors if we want to. By calling fill again after drawing the rectangle, we can give this a color like a purple color maybe. And we can see now that they have two different colors representing them. So my challenge to you before next episode, go ahead and download processing if you haven't already, and try to make a little face. Try to have a circle or an ellipse for the head, maybe two circles for the eyes, some rectangles as eyebrows, and then try to make a little cute mouth. And heck, if you're feeling inventive, go to the processing webpage and then go to the reference, and you can see how they draw different shapes, how to make your custom shapes, how to make a triangle or a hexagon, things like that. And just experiment a little bit, try different colors, see if you can make the shapes blend together somehow. And with that being said, I hope you all enjoyed and thought that this was informative. And I look forward to seeing you in the next one. Take care.